So this session is Introduction to Einstein Prediction Builder. My name is Keverly Strand. I work on the product marketing team for Einstein. And this is Sarah Asher, and she works on the product management team for Einstein.
Hi, everyone.
How many of you went to Dreamforce this year? So quite a few of you. One of the things we heard for feedback was to show more use cases for Einstein Prediction Builder. So we're going to cover a couple of those today. We're going to talk about what's in pilot. So just remember to keep your buying decisions based on what is available versus what's in pilot. All right, so we're going to start this a little unconventionally with a story. So back in 2007, you're probably wondering why there's a cat on the screen. Back in 2007, the New England Journal of Medicine did a report on a 2-year-old cat named Oscar. Oscar was really good at predicting when a patient was about to die. I know this is very sad. What he would do is he would sniff the air, curl up in a ball on a patient's bed, but this was an alert to the doctors and the staff to call in families to say their last respects. So this was actually a good thing.
Huh. You know, that sounds like that cat is almost like a machine learning algorithm, right? It used data, I don't know what data, but it used data to sort of predict when someone was going to pass away and then jump on them.
That's a perfect example. Exactly why we're talking about this. So how can we make predictions for our businesses? Sarah, we're going to show how easy that can be.
Okay. So do you want to first talk about our use case?
Sure. So we're going to start out in the finance industry with accounts receivable specialists. So some of the things that they're concerned about are reducing time spent on chasing down unpaid invoices. Nobody wants to do that, right? Nobody wants to do collection calls, which is another aspect of their business that they have to do. And they also want to help customers find the best payment methods because it's going to make their job easier because people are going to pay on time.
Okay.
So let's run into that on a demo.
Sounds good. Let me get up Salesforce. Okay.
Perfect. Okay. Would you mind pulling up I'm going to be the account receivable person.
Sounds good.
Would you pull up my invoices?
Be happy to.
Awesome. So looking at this, normally it's just a bunch of invoices. It doesn't really tell me much. And I would go start from the top. Is there a way that I can predict when a payment is going to be late?
Yeah, actually there is, and that's actually a really good use case for Einstein Prediction Builder. So let me run through and create your prediction for you.
Perfect.
So as an admin, I'm going to just head up to the setup pages and click on Einstein Prediction Builder. Okay. So let's create a new prediction. I'm just going to call this likelihood to be late. What do you want to call it?
No, I think that sounds great.
Okay. I can't spell. Let's try that again. To be late. There we go. Good enough. Okay. So the first thing we need to do is choose the object to predict. In this case, we are predicting whether an invoice is likely to be late or not. So it makes sense. The object would be?
An invoice.
Good job. Okay, we're making some people over here laugh a lot. Okay, so the next thing we have to do is we need to pick a field to predict. So let me take off my admin hat for a second and put on sort of the PM hat, which is Einstein is very smart, and it's going to create a really cool prediction for you. But it can't read your mind, which means that you have to give us a certain amount of information for us to do this prediction. In this case, we're trying to predict whether something is going to be late or not. So as an admin, I created a field. And the field I created is basically payment overdue. And so basically, I have a trigger that what's going to happen is that as soon as it's maybe like 3 days after the invoice date and they still haven't paid, it automatically checks in and says, OK, this thing is overdue. And otherwise, it's just left regular.
Okay.
OK, so not too hard to set up. So I've set up one that does that. And I think I called it payment. Where is it? Payment overdue. So just a checkbox. OK, this gives an example prediction of what this is going to look like. So basically, we're predicting the likelihood that a payment is going to be overdue, likelihood that this box is going to be checked, and we're going to give a confidence. So if the confidence number is super high, it means that, yeah, this person, they're slackers. You're going to want to go bug them. And if the number is super low, it means that these are actually people who pay on time all the time. You probably don't need to bug them.
Definitely not our Salesforce customers.
Oh, no, they all pay. They're wonderful. OK, so the next thing is choose where to save your prediction. So what Einstein does is it basically creates the number, that confidence that we showed you in the previous screen. And so we need a place to store that. In the pilot version, we just store it into a numeric custom field. And it'll be slightly different when we go GA. But for now, store it in a custom field. And so I've already created it. It's called likelihood of late payment, and it's just numeric, nothing special about it. OK, confirm fields to make a prediction. So these are the fields that we're going to base your prediction on. And so if you look at a couple of them, you've got like late payment in the last 100 days. That is something that's probably going to be really good to determine whether someone's going to pay on time or not, right? So that's a field that you'd probably want to use. And honestly, most of the fields you have will either be useful, so you should check them, or irrelevant, so you just leave them checked and that's fine, and we'll figure out if they're important or not. There are fields, however, you may want to remove from your system. And so let me give you some examples of this. If there's a field that you used to use all the time and then you've stopped using, it's basically a dead field, you probably want to deselect it so that you don't want us to make predictions based on that field because you're not really using it anymore, even if it's still there for the old data. Does that make sense? Yeah. In this case, it doesn't really matter too much, but for some types of models, you want to make sure that you don't put bias into your models. So if you have like gender or ethnicity or things like that, you may want to remove those from your model as well. And then finally, other fields you may want to remove are fields that you don't want to use for the prediction because it's something called Einstein bias. It's because you wouldn't have that information when you want to do the prediction. So an example of that is if you have like this invoice paid late, and then you have a field like emailed them to yell at them because they paid late, you don't want to use that in something in your model because it's not something you would know when you're trying to do a score. Hopefully that makes sense. If not, come talk to me afterwards and I'll try to explain it. OK, so we can unselect some fields. So I'm going to unselect status because that actually has information about overdue versus not due. OK, want to focus on a particular segment of your data. In general, you may not actually want to create a prediction on every single invoice. And so therefore, you may want to limit it to a smaller amount. And so that's a question for you. Do you want to do it on all the invoices or something smaller?
Well, I'd really like to focus on our larger invoices, so maybe 50,000 and above.
OK. Here we are. So we actually have this account overall value. So what I'm going to do is set it to say I want to use the, sorry, let me just fill this out and then I'll say what I'm doing. Does not equal. So basically, I've just filled this out to be with the bands of account values. I don't want it to be the smaller bands. I only want to use the larger bands. Perfect. OK. What records should Einstein use as examples? So again, going back to the PM hat, what is machine learning? Machine learning is basically using historical examples or historical data, finding patterns in there, and using that to predict the future. Now, you can do that, but we need to know what are the good use cases. Which are the ones that we know that if it's checked, it was paid on time, and if it wasn't checked, we know that I'm sorry, wrong way. If they, we know whether they've paid on time or not. And the example for this is with invoices. Basically, at some point, the invoice closes, and at that point, you know whether they paid on time or not. So that's the type of information you would have here. So in this case, I'm going to have the collection status equals to closed, because those are the ones that we know whether they paid or not. OK, that's it. Are you happy with the prediction?
I believe so. It looks kind of...
OK. Yeah. Then we build the prediction, and we're done. And what happens at this point is this configuration gets sent over to the Einstein platform, and we create a model for you. And then we start shooting back predictions on an hourly cadence.
How am I going to see those predictions?
OK. So do you remember where I showed you where I said, hey, we're writing back to basically like a numeric custom field?
Mm-hmm.
So let's take a look at a slightly different list. There we are.
Wow, this looks so much better than the last. I can actually tell which ones I need to focus on.
Exactly.
Obviously, that global media looks kind of important, so I will focus there first.
Yes, I would go talk to them immediately.
Awesome. Is there a way that I can figure out or see why it's scoring the way it's scoring?
Yeah, I'll show you something. So this is a sneak peek of future functionality, but I'll show it to you right now anyways, just so you can get an idea of where we're headed. So what I'm going to do is edit the page. Oh, whoops, it's already there. I already left it there from last time. That's OK. This is basically just a Lightning component that we've dropped into the screen, that one up in the upper right-hand corner. And you'll notice it gives the number, 77%, but then it also gives reasons for why we gave the prediction as we did. We give the top positive factors, and we give negative factors as well. So if you look at the top positive factors, some of them are going to be probably pretty obvious, and you'll look at them and be like, well, of course. Like, for example, late payment is in last 100 days is 3. makes sense that that would be a predictor. Some of them hopefully will come up with insights that you wouldn't necessarily have thought of. Like for example, payment method being wire transfer. Logically, it makes sense, right? Because that's manual. And if you're doing a manual process to pay, people are going to forget, they're going to go on vacation, whatever else, you're more likely to pay late, as opposed to something like credit card, where it's an automatic payment when you just register it through.
This is really insightful because, like you said, the wire transfer, if I actually got the customer to switch to automatic payments, maybe it would increase their score, so more likely to pay?
Yeah, no, that is very true. And actually, that's something that you can do. So we have a dynamic component underneath, which you can't see. So let me go to the screen and go down like that. And this dynamic component is basically set to show if the score is very high and they're on wire transfer, then you can basically leave a note for you, the agent on this case, to say like, hey, it's time to make these guys an offer. Why don't you consider switching to credit cards? It'll make both of us happier. And so that's one thing you can do. And the other thing you can do is use these things in Process Builder. So in this particular case, because the score was so high, it basically created a case on the system so that you would get a warning like, hey, this is someone you need to deal with immediately. So it can also be used to change your business processes in addition to just changing the GUI.
Oh, I love that. It's going to make my job so much faster.
Glad to be of service.
All right. Well, could we jump into maybe another use case?
Sure.
This one might apply more to the audience here. So an IT project manager.
Okay.
So some of the things that you're concerned about if you're an IT project manager are making sure you have the right resources on the right task. You also want to make sure you're managing project scope and budget and timeline, right? And then if you see anything come up, you want to escalate those risks to management or figure out what to do next. So if we were to take Einstein Prediction Builder, what sort of prediction would we want to have for that?
Okay, well, we're basically trying to predict days, right? We're trying to predict number of days. And that's also something that Einstein Prediction Builder can do. And through the magic of Demoland, we have already set that up for you.
Love it.
So let me run over here. And we've previously created a prediction for you. And it's basically called project duration. And that's going to predict the number of days that something is likely to take.
Perfect, because then if we've scheduled 30 days, but it's actually taking 43, we'll know right ahead, like in advance, that we need to think about how can we take resources from that project and put it on something else, or add resources where we need to, that kind of thing.
Exactly. And so if you take a look, it's the same sort of thing where then you'll be able to do just the same things you did in this other use case. You can use it in Process Builder. You can create dynamic components. Oops. And you'll be able to eventually also have a component which will give you information for why we gave the number that we gave.
Perfect. So now you've seen 2 use cases for Einstein Prediction Builder, and you've heard about them, and you can ask more questions later. Let's see. We'll go back to the slide.
Whoops.
So if you want to learn more, sorry, Sarah.
That's OK.
If you want to learn more, we have Einstein Outpost over to the right, back in the back. Be sure to visit there. We're having workshops throughout the day, every half an hour. Or you can come to our keynote at 1:30. It's going to be awesome. I guarantee it. And then go to trailhead.einstein.com, and you can take all the amazing trails that we offer and learn more about it that way, too.
OK.
Thank you all.
Thank you. Are there any questions? Yeah. Yes, please.
Oh.
Go ahead. Uh-huh.
How did Einstein decide this input is more important? Like, how did it rank one of the inputs, or did it
OK, so the question was basically, in the page where you decide what fields to use in the model, what does Einstein do with that? How does it know what's important and what's not important? How does it rank it? And so that gets a little into the machine learning that happens behind the scenes. So what we basically do, and anyone who's not interested in this, feel free to leave. But underneath what happens is that we take those fields that you've chose and we turn them into a set of features. And that's the first thing we do. The fields as they are just there aren't necessarily the exact type of fields you end up wanting to use for machine learning. So for example, if you've got numeric fields, you want to do something called normalization. And that's basically, if you're trying to predict something and it's using like someone's income, which has a huge range from like 0 to 1 million, and someone's shoe size, which has a range from like 5 to 12, you basically want to squeeze them so they look like they're the same size for the models. So like we automatically take these fields and we transform them into things that we think are going to be useful. And for those who are familiar with data science, like if you're taking a pick list, we basically like do one-hot encoding. But we also create other features. So for example, if it's an email, we'll extract the domain because email on its own is not a very good predictor of anything. However, there's information in the email string that we can use that could be predictive, again, like domain or whether it's edu versus com or whatever else. And so anyways, regardless, whatever field type it is, we create a bunch of different features from it. And then we go through a sanity checker, a sanity checker stage. And what that does is it goes through this huge list of features that we've created. And then it basically narrows it down. And we get rid of the ones that we think are not important and keep the ones which we think are important. And then we also remove ones which we think are too good. Like if it's matched exactly with what you're predicting, we're going to throw it out as well. And that's how we come up with our list. And then the algorithms themselves will basically, depending on the algorithms, they're going to end up weighting the individual features. Like if you're using logistic regression, for example, for that we use regularization to figure out like the different weights of things. Cool. Right behind, and then you. Mostly.
Information from related objects.
Okay,
So you
cool.
were showing the demo
On one object.
object,
That is true.
but my use case is actually having information from even 3 different objects.
Okay, so the question is, right now this demo was just on one object, and the question is, can we handle related objects? And the quick answer is not yet, but we are going to. So for the first version, it's just going to be on the one object, and then the next big thing that we really want to tackle is actually starting to do related objects, because you do want to be able to use their parent and children objects to fill it in, and so that is coming, and we're already thinking about it and working on it, but it's not quite ready for this yet. Oh man, I plead the fifth on that one. And then there was a question right up in front.
Einstein only worked in Lightning.
Okay, so the question is whether Einstein only works in Lightning. So the answer to that is that the setup pages are only done in Lightning. So your admin needs to be in Lightning in order to use it. That being said, the data that we're sending back is just data, which means that it can be used in Classic or in Lightning. Now we're going to create components, and we'll probably have fancy Lightning components at some point, and I think to be determined whether we also do Classic components. But the data itself is data, so you can always use it. Are there any other questions from anyone?
Oh, right over here.
Oh, where? Yeah, come. How many fields can we? Okay, in that list. Yeah. So the question is, how many fields can we use as fields for the model to base your prediction on? And the answer to that is how many you got. In general, there's not necessarily going to be a limit to the number of fields. The little star caveat on that is that occasionally that the amount of data is overwhelming for our SOQL query. So if that happens, then we may run into trouble. But the machine learning algorithms are set up to handle very wide data. Oh, is there a minimum number? Not necessarily. I mean, you could create a prediction on one field and one thing if you really wanted to. Like, you could probably predict someone's height based on their shoe size, and it would be an OK model, potentially, right? But in general, the way to think of it is the more data, the better. And so you'd rather have more fields and not just use just like 1 or 2. But yeah, I mean, there are good models out there that only use 10 fields, and that's fine, OK. Any other questions?
All right,
I will
thank
take
you
that as
guys.
a no. Thank you very much.